Welcome back. Flight Radio Telephone Operator Exam Prep Part 2. So hopefully you've gone through Part 1 and you've done the Part 1 test questions and you've got 100% in those. If not, keep going over it until you can get every question right. And you stand a fair chance of passing the exam. Actually better than fair. A lot of those questions that you see will appear on the exam in one form or another. Pilots are responsible for maintaining a listening watch on appropriate frequencies at all times and communicating clearly using standard phraseology. Most countries have adopted the same aviation radio communication phraseology, which is used to streamline radio communications. The advantages are avoiding miscommunication and messages are short, freeing up radio waves for other transmissions. Very important in Class C and above airspace. While these advantages are gained, there are several key points that must be followed at all times. All communication must be in English. Terms such as thank you, please and sorry should be avoided because there's not really much time for that. Standard terminology should be used at all times, and we will be focusing on phraseology and terminology in this particular part. Transmitting of individual letters is common in aviation, and the phonetic alphabet is used to avoid miscommunication. When pronouncing words in the phonetic alphabet, certain syllables must be emphasized. In the below list some example syllables that should be emphasized. And what can't be emphasized enough is that you are guaranteed to have 3, 4, 5 questions in the exam that will test your understanding of syllable pronunciation. So just knowing that it is A for Alpha, B for Bravo, C for Charlie is not quite enough. So when it gets down to decimal, 100, 1000, they will be asking you and giving you a selected set of possible answers in various forms. So get to grips with this, it's very important. Generally, all numbers are transmitted as individual digits except for altitude, cloud height, visibility, and runway visual range, where whole hundreds or whole thousands are spoken. Now below is an example or set of examples. Now if you've noticed this, the pronunciations are critically important as these will be the ones that will be asked of you in the exam. So 150, but you'll also get an alternate answer of 150. You have to get the pronunciation right. Pause this, read through it, memorize it, then carry on playing the video. Radio frequencies require pilots to say decimal when pronouncing the frequency. Please remember that. That's another common pronunciation catch in some of the exam questions. Some answers will have decimal in it, some of them will have decimal in it, and some won't have anything other than the dot. Make sure that you remember that. Again, have a read through this, pause the video, make sure that you memorize things like 1,500 meters. Very, very important. These questions can be the pass or fail. Pause it, read through it, and then move on with the video. When transmitting time, each digit should be pronounced separately. Only the minutes of the hour are normally required if it's the same hour. However, the hour should be included if there is any possibility for confusion. So if you're holding outside of Class C airspace and you are given an expected entry time of 0803 and it's 0745, then it is important to carry that over. Remember that the hours come to avoid any confusion, but you can get a voice prompt from a controller just giving you the last 2 digits, which means it's going to be within that hour. Procedure words and phrases and the readability scale. The following list of words and phrases are used to provide clear communication so that transmissions are not misunderstood. Keep brief and to the point. Pilots should always use these standard phrases. However, if a pilot forgets the correct terminology, reverting to plain English is perfectly acceptable, but not in the exam. If there is no standard terminology for your request, use plain English. So, Pause, read through this, make sure you memorize it, because these are also exam questions. Here's some more for you to pause, read through and get right. Most importantly, remember the readability scale. You can get up to 2 questions on the exam for that. 1, unreadable. 2, readable now and then. 3, which is a common one, readable with difficulty. 4, readable. 5, perfectly readable. Pause the video, read through the meanings and phraseology of these parts. There are some exam questions, although not every exam carries them. All stations must have a call sign, which is a name in which is used to address a message to a particular station. Most light aircraft call signs are permanent. Others, such as airliners, have a call sign that alters from flight to flight. Civil Aviation Part 91.249A and B state the rules for using this aircraft call sign. Now you'll have this within radio telecommunication. You will also have this section in air law, so save some time, get used to it now. If required to communicate by radio telephony under the civil aviation rules, a pilot in command of the New Zealand registered aircraft must use one of the following radio telephony call signs. The telephony designator of the aircraft operating agency as approved by the director, followed by the flight identification. For example, Massey 45, Medilift 01. The telephone designator of an aircraft operating agency as approved by the director, followed by the last 3 letters of the aircraft registration markings. Example, Link Mike Alpha Charlie or Medilift Lima Foxtrot Whiskey. The name of the aircraft manufacturer or the aircraft model and the last 3 letters of the aircraft registration markings. Example, Cherokee Delta Foxtrot Lima, Diamond Star Papa Juliet Tango, Cessna Whiskey Alpha Foxtrot. Notwithstanding paragraph Alpha 2, the pilot in command may, after establishing 2-way communication with the appropriate ATS unit, use an abbreviated call sign consisting of the last 3 letters of the aircraft registration marking. Note that Part C states 1 and 2 above are only able to be used by the holder of an air operator certificate, commercial operators, which will include regular air transport services, medical transfer, emergency flights, and search and rescue flights or aircraft flown on police operation, which is authorised by the Commissioner of Police. The only difference between 1 and 2 is the use of the letters and the numbers. Most light training aircraft and private operators use 3, which can be shortened to the abbreviated call sign mentioned in Part B, Cherokee Delta Foxtrot Lima, or becomes Delta Foxtrot Lima, once communication has been established. There are several different types of control and other assistance provided to aircraft by air traffic services. This could be an aircraft being controlled by a different ATC, whereby the pilot of the aircraft must do what the controller instructs, especially within Class C, unless it breaks any civil aviation laws. Through to flight information services, provide pilots with information to assist with their flight as it progresses in uncontrolled airspace. Ground stations are identified by the name and of the location followed by the service. For example, control, area and approach control including area and approach radar. Approach control where provided as a separate function. Arrival is the approach control radar arrivals. Departure, approach control radar departures. Tower, aerodrome control or aeronautical and approach area control where these services are provided from an aerodrome control tower. Ground, surface movement control including clearance delivery. Radar, area or approach control radar on a discrete frequency. Flight service, aerodrome flight information service. Information, area flight information services. Delivery, which is clearance delivery. Radio, air to ground service. And Unicom, self-explanatory Unicom services. So for example, in Param you have Param Flight Service, Wellington Control, at Wellington City Centre, Nelson Tower, and Christchurch information. Once again, the name and the location of the service may be omitted provided that satisfactory communication has already been established. Now, all of those previous services we just discussed have their own frequency. The frequency a pilot must be tuned into when operating in a certain place is listed in several documents. Now again, this is a very common exam question. What documents list radio frequencies? So, the aerodrome charts in the AIPs 2, 3 and 4, and the communications listing, volumes 2, 3 and 4, and on the FISCOM charts for 2, 3 and 4. You will also find them on visual planning and visual navigation sites. Did have a friend who recently just sent his test. He listed on what documents can you find tower frequencies. It was given VNC, VPC, VPC and VNC, and the AIP. Excuse me. He selected VNC, but it is actually VPC and VNC. An aerodrome chart on the left and the visual navigation chart on the right with the frequencies that pilots should be tuned into are circled. Aerodrome charts may have more than one frequency depending on the traffic volume, and charts usually have many frequencies on them, so pilots must make sure that they know the aircraft's position and which frequency they are to be on at all times. Always the pilot in command's responsibility. Above is an example of the communication listing from AIP volume 2, 3 and 4. This lists all of the frequencies a pilot may require when flying to a destination. As you can see under the services or facilities box, there can be many services at one airport. Working across the table, you can see approach control, tower, and flight information service. These can all be addressed as Queenstown Tower on frequency 118.1 or 128.9. And the hours of operation for the services, the HO component. The H24 means that the service or facility is available 24 hours a day. H0 means that the operating hours are to meet operational requirements only. If two frequencies are listed, the first is the primary and the next is the alternate. There are only two FISCOM charts, one in the North Island and the other in the South. South Island chart from AMP volume 2, 3 and 4 is depicted here in the picture. These charts show where long-range VHF communications can be maintained by aircrafts en route above 4,000 feet. These charts show where a flight in uncontrolled airspace can expect to make contact with the service listed. Areas with a triangle next to them show that high-frequency communications are available. For all of the pre-mentioned documents, it is the pilot's responsibility to ensure that the documents used to find radio frequencies or other information are up to date and or are the latest available. The information in the IPs or the VPCs and VNCs can temporarily be superseded by NOTAMs, which are the temporary notices for pilots to be aware before flying. Further information on NOTAMs you can always pick up with your instructor. Establishing communications and procedures for exchanging messages. Now, we're going to use various different icons here to be able to represent each one. But from this point onwards, we'll be looking at the messages sent from an aircraft to the various different air traffic services, which are made up of air traffic control, AFIS, radar or flight information. And the following symbols will be used. Radio messages are sent from one station to another, e.g. controller to aircraft, aircraft to aircraft, aircraft to controller. From time to time there's a need for a general broadcast to all stations listening out on that frequency, and we will be covering this here. When establishing communications, an aircraft should use the full call sign of both the aircraft and the aeronautical station. Use of the name of the aircraft manufacturer or the aircraft model or type is optional. Pilots can assess whether the aircraft type could be helpful to the recipient for recognition or sequencing purposes. So please remember, who are you addressing and who you are. So an example would be Nelson Tower, Cessna, Foxtrot, Lima, Charlie. The reply will usually, the reply will be the use of the call sign, station's call sign, and the receiving station's call sign. This is considered an invitation to proceed with the transmission, and you've established communication once in receipt of that. The phrase "go ahead" is not to be used. So your reply would be Foxtrot Lima Charlie, Nelson Tower. Oh, sorry, beg your pardon, that's the wrong way around. The tower will respond, Foxtrot Lima Charlie, Nelson Tower. After contact has been established, continuous communication is permitted without further identification or call sign until termination of the contact, provided no mistakes in identity is likely to occur. Another example, Foxtrot Lima Charlie, Matai Saddle, 2,500 feet, request clearance to enter control zone. Control will then respond, Foxtrot Lima Charlie, cleared to enter zone, 2,500 feet or below, report on final approach. Both the ground station's call sign and the aircraft have been dropped, as there is no way of mistaking the identity. The communication's been established. You can go ahead and proceed until that communication has completed. When a ground station wishes to broadcast information, or an aircraft wishes to broadcast information to an aircraft in its vicinity, the message should be prefaced by the call "all stations." No reply is expected to general calls unless individual stations are subsequently called upon to acknowledge receipt. If there is doubt that the message has been correctly received, a repetition of the message should be requested in full or in part by using one of the following phrases. Say again. Say again the item. Say again all before. Say again all after. Say again all between and that will repeat part of that message. If an error has been made during the transmission, it can be corrected by adding the word correction and immediately rectifying the example. Foxtrot Lima Charlie, wind 210 degrees, 18 knots, correction 28 knots. Acknowledging a message depends on if the message requires a readback or not. A readback is used to make sure effective communication has taken place. Communicating via radio in the busy aircraft environment with differing levels of equipment and clarity make it more likely that a word or phrase is misheard. The requirement to read back instructions is to ensure that the message has not only been sent but received and understood by the person it was directed at. It should also be noted that controllers are required to receive the readback in the following situations and will ask for readback if the pilot responds incorrectly. The pilot is required to acknowledge receipt of the following ATC clearances, information or instructions with a full readback followed by the aircraft call sign. Air traffic control route, approach and departure clearances, clearances to VFR flights to operated within controlled airspace, clearances including conditional clearances to operate on the manoeuvring area at a controlled aerodrome, including clearance to land on or take off from any runway, clearance to enter, cross, taxi or backtrack on any runway, instructions to remain on or hold clear of any runway, taxi instructions including a taxi route and holding points where specified runways in use. Always respond with transponder codes, level instructions, heading and speed instructions, altimeter settings, and frequency after frequency change instructions. In all of those cases, make a full readback followed by the aircraft call sign. It's very common to see a couple of exam questions with what you should read back after receiving a message. Read those very carefully, but also make sure that you understand what you have to read back. Readback exceptions for VFR aircraft. When a VFR aircraft is cleared by ATC to route via a published arrival or departure procedure that is identical to that initially requested by a pilot, there is no requirement for the pilot to read back the clearance in full. The aircraft must transmit its call sign as an acknowledgement. Items which you never have to read back to a controller include time, For obvious reasons, time will change by the time you've read it back. It makes no sense to read it. Weather information, same thing. Weather can change. A request to report at a certain point. Just a given, remember it, and then report back. If a readback is not required, the pilot should reply with the call sign only. No readback required. For example, Foxtrot Lima Charlie, time is 4:07. You respond, Foxtrot Lima Charlie. ATIS is used at most controlled aerodromes. While ATC is on watch, the ATIS constantly broadcasts weather and other aeronautical information such as the runway in use on a set frequency that pilots know what conditions and runway to expect when travelling to or departing from that aerodrome. This information is usually updated as it changes by the control service. Working in the tower so that it's always the most current information available. At aerodromes where ATC goes off watch, no ATIS is provided until ATC returns. The ATIS broadcast will include a statement saying the following. On first contact with the aerodrome, tower approach control, notify receipt of information. When you make your first contact with the aerodrome's tower or approach control, you must read back the receipt using the following wording. Information Alpha, information Charlie, information Golf in your radio call. This way ATC units you are talking to know that you have the latest information and understand what conditions are at the aerodrome. Information included in the ATIS broadcast include name of the aerodrome and the terminal information, code letter for the broadcast, time issued, the approach a pilot can expect, the runway in use, surface conditions of that runway, other operational information, for example, whether taxiways are open or closed, surface wind in degrees magnetic and knots, visibility, current weather, cloud, height and octaves, temperature and dew point. The statement on first contact with aerodrome tower approach control notify receipt of information. Confirms that you have acknowledged that you've been receipt of all that information. You may have the wrong information and then tower will send you back to be able to collect the correct identifier. Unicom is available at some unattended aerodromes. A Unicom service is a base radio which is staffed by local qualified persons who do not work for Airways New Zealand. While on duty, Unicom can provide information to pilots such as base weather information, wind, visibility, cloud cover, temperatures and QNH. AWIBs, current aerodrome information and conditions, base radio service, a telephone service during published hours. Where a Unicom station is present and on watch, operators often have other duties and may not be listening in at all times. They may pass on this limited information on request. For instance, a pilot may ask for surface wind conditions to ascertain a preferred runway. The Unicom service operators will not designate the runway in use. On request, Unicom service operators may relay information on the general location of aircraft known to them. Unicom must not interpret that information. Unicom is not an air traffic service and cannot provide traffic information. The information given is not traffic information, but known aircraft, which means that there is a distinct possibility of unknown aircraft. A Unicom service will not be in a control zone, and staff are not controllers, so it is always imperative that you keep a listening watch. Aerodrome Frequency Response Unit. An AFRU is often provided at aerodromes with Unicom. An AFRU provides confirmation to pilots that they are on the correct Unicom frequency and that the aircraft radio is working properly. The AFRU automatically transmit the aerodrome call sign and frequency where there have been no transmissions for a set period of time, usually the last 5 minutes. If there have been no transmissions for longer than this period of time, then an aircraft makes a radio call to the AFRU, will reply with the Ardmore 118.1, etc. If there have been transmissions lasting longer than 3 seconds in the preceding time period, each aircraft transmission will be followed by a single beep. Aerodrome weather information broadcasts, AWIBs. These are used on unattended aerodromes, and an unattended aerodrome is an aerodrome without ATC or any control service. An AWIB service provides similar information to an ATIS at controlled aerodromes. Both provide pre-recorded information on runway in use, weather, and all the stuff that we talked about before. Unlike ATIS, where the information is constantly broadcast on a set frequency, the AWIB information may be retrieved in several different ways. At some aerodromes, the pilots just need to select the correct frequency, just like ATIS. But at other aerodromes, you might find you have to select the frequency and then push the mic to transmit. And maybe even a select set of numbered times. Same as if you have pre-designated landing light confirmations. Select the AWIB frequency, then push the microphone transmit button 5 times in 5 seconds for AWIB information to start transmitting. To find out how to activate the AWIB at an aerodrome you're flying to, check the Aerodrome AIP Volume 4. This is always a fun one. Defining the airspace you're flying in. Controlled airspace is divided into different types and classes. There are several different types of controlled airspace, and the two most common being CTRs, control zones, or control areas, CTAs. At busy airports, there's usually a terminal control area and a control area called an upper controlled area. It can be found above 9,500 feet in some areas. These can either be Class C or Class D airspace. Airspace that touches the Earth's surface is referred to a controlled zone, and they are found around controlled airports. A controlled area that does not extend down to the Earth's surface is called a controlled area. These are large areas of airspace that can link control zones together so that flights can remain in controlled airspace between zones, aerodromes. Control provides different services within either Class C or Class D airspace. It is important for pilots to know and understand what separation will be provided to them in the different classes of airspace. Class C, controlled airspace, CTRs or CTAs, separation provides VFR flights from IFR flights, special VFR flights from IFR flights, special VFR from other special VFR when visibility is less than 5K. Now that is a very, very common question. Control will not separate VFR flights from other VFR flights. Now in Class D, separation will be provided between special VFR and IFR, special VFR from other special VFR when visibility is less than 5K. Control will not separate VFR from IFR, and control will not separate VFR from VFR. Remember, as Class C and D airspace are both controlled airspaces, all flights, IFR, VFR and special VFR, require a clearance to enter before entering. On the VNC, control zones are marked by dark blue lines, and they always touch the surface of the Earth. The lowest level will always read SFC, or surface. On the left-hand side of the airspace information, you will see a C or a D, which informs us that the class of airspace of that particular control zone. Now, if you can see the black oval on the top right, control areas, CTAs, are marked with purple lines as they never touch the surface of the Earth at its lowest level, and it will be indicated on what that lowest level is. So, if you see under the red circle, you have Class C airspace, LL2500 for Ohio on 125.1. Indicates that the lower level, or the base level, starts at 2,500. Position reports are an essential part of radio communication and are used for a number of reasons. 1. To obtain entrance into a controlled airspace so that ATC know where you are on their screen and assess how fit you are, or how to fit you in with the other aircraft in that zone. Number 2, traffic information and avoidance. Other pilots listening out will be able to assess your position relative to themselves, which will help to build a picture of what other aircraft are around them. Air traffic services such as Unicom or AFIS use this information to provide other aircraft with traffic information. And 3, search and rescue. If you make regular position reports, your flight's progress is monitored by others and narrows the area down to search for you if you fail to land at your destination or fall out of the sky like a brick. Position reports are required when requesting to either Class C or D airspace for entry, when requested by control in Class C or D airspace, and they will always ask and you will always comply. At the entry and at specified locations and intervals when operating in an MBZ. And lastly, prior to entry into a restricted or military operating area if ATC is the controlling authority. A position report includes the following information: identification, the call sign, and if the aircraft has a discrete transponder code, you send that as well. Present position, such as overhead Shannon or 1 mile seaward of Otaki Beach. Time at the position. If the position you gave was a few minutes ago, then they can calculate where you should be now. The altitude. The intentions. The destination. For example, your nest landing point and estimated time of arrival. An ETA is not always required when transiting through a control area. And a clearance request. Only required if requesting a clearance into control airspace. Just remember who you are, where you are, and what you want. While in controlled airspace, position reports must be passed to ATC when requested, which could be once reaching a reporting point or at set times. Outside of controlled airspace, there is no requirement to make position reports. However, it's good airmanship to contact the appropriate ATS unit as soon as practical after exiting a control zone or after takeoff from an uncontrolled aerodrome so that they're aware of your position. The frequency for FISCOM in your area can be found on your VNC or in the FISCOM charts in the AIP. Usually addressed Christchurch information, they will record your permission and update your ETA if it changes. Near controlled aerodromes. If you are going to pass near a controlled aerodrome, you may enter that control zone, which means you will have to require and request clearance first. Usually you're able to fly around the outside of the control zone. However, in doing this, you need to make sure you remain well clear of the zone. VFR aircraft clipping the edges of control zone pose a threat to departing and arriving aircraft and are a major problem for the flight safety because they don't know you're there. Near flight service aerodromes. Flight service aerodromes, AFIS, such as Param, are uncontrolled. If you're going to fly within the vicinity of an aerodrome that is manned by an AFIS, you are required to maintain a continuous listening watch and adhere to the rules for flying near unattended aerodromes, i.e. no control or AFIS, which are below. Near unattended aerodromes, there is no requirement to make radio calls when in the vicinity of an unattended aerodrome. It is considered good airmanship to make a radio call if you are inbound to that aerodrome or transiting nearby to make a position report on that frequency for that aerodrome. Transiting nearby is considered within 5 to 10 nautical miles below 3,000 feet. It's highlighted in green because it is the most common exam question out there. Radio calls are made where there is no control or flight service to address. Should be made using aerodrome traffic, so Masterton traffic, Param traffic. An IFR or VFR aircraft that requires entry into a controlled airspace should make their position report, including requests to the appropriate ATS unit in sufficient time to allow ATC to assess the traffic situation and issue a clearance prior to the aircraft reaching that controlled airspace. A general rule of thumb for how far out you should make your first call with control prior to entering the airspace is when you are 10 miles from reaching that airspace boundary. It may be that because of prevailing traffic situations, a clearance cannot be issued immediately. A transponder squawk code may be issued to assist ATC in assessing the traffic situation. This does not constitute a clearance to enter the controlled airspace. A little bit of an example below. If we look at the chart below and want to fly along the red line from Kopataroa to Taonui at 2,000 feet, you can see shortly after takeoff you will be entering Ohakia's control area, which is Class C airspace, as you can see. The frequency to call Ohakia on is 125.1. You'll make the call. Ohakia control, Cessna 152 Echo Lima Alpha. You will, from Ohakia control, you will receive a go-ahead. Echo Lima Alpha, Ohakia control. You'll respond. Echo Lima Alpha, overhead Kopataroa 2,000 feet, tracking to Taonui via Karianga, request clearance to enter controlled airspace. You'll receive, from control, Echo Lima Alpha, squawk 3662. You will, because it's a mandatory, respond, squawk 3662 Echo Lima Alpha. Once the controller has identified you on radar and has assessed how best to clear your aircraft, you may be cleared to enter the controlled airspace, or be advised that entry is not available at this time. You'll hear Echo Lima Alpha identified, cleared to enter controlled airspace via Palmerston, 2,000 feet, QNH 1003. You'll respond, cleared to enter controlled airspace via Palmerston, 2,000 feet, QNH 1003, Echo Lima Alpha. And you will get a readback correct from the tower. You must fly from your present position directly to Palmerston and then onwards to Taonui at 2,000 feet. No further position reports are required, but you must maintain a continuous listening watch on Ohakia's frequency in case they want you to change the clearance they have issued you. Clearance to enter control zones and control areas should be dealt with as described previously. If unsure of the instructions passed you, make sure you clarify with ATC what is expected of you and then carry out those instructions to the latter. Flights leaving controlled airspace will normally be given a track or a specific point by way to leave, together with any other relevant instructions necessary to ensure separation and your aircraft safety and the safety around you. An aircraft may be cleared to leave controlled airspace by descent. For example, Kilo Alpha Zulu, leave controlled airspace, in descent, report passing 5,500 feet, QNH 1014, no reported IFR traffic. You'll respond, leaving controlled airspace, in descent, Wilco 1014, nil traffic, Kilo Alpha Zulu. Phrases that you may hear from ATC are listed below. Make sure you read them and make sure you read and understand the descriptions. Pause the video, read through them, then resume. When operators in controlled airspace, Class G, in uncontrolled airspace, there is no requirement to make radio calls. However, it is still the pilot's responsibility to ensure flight safety by seeing and avoiding other aircraft. This can be assisted greatly by you and other pilots operating in uncontrolled airspace, making position reports so that anyone on the same frequency is informed of your location and intentions. Also note that uncontrolled Class G airspace can be part of a mandatory broadcast zone of common frequencies. We will now look at that radio procedure. MBZs, mandatory broadcast zones. These have been established around uncontrolled aerodromes that have high volumes of traffic per am tailpo. The reason for this is so pilots operating in uncontrolled airspace, which also have mandatory broadcast zones, are required to make position reports at set positions or times to enhance the safety for all aircraft operating in that area. Reports must be made with call sign, position, altitude, intent. Memorize these, very important, anything in green. On entering MBZ, joining the circuit, before entering any runway in the MBZ, advise runway to be used at specified time intervals in the MBZ text box for that area of VNC. And all MBZs are marked on VNCs by lines made up of blue circles. Wanganui traffic, Cessna Juliet Echo November, seaward of Kaiui, 1,000 feet, tracking southeast to join for runway 11. Common frequency zones, similar to MBZs, however, there is no requirement to make reports even if a time for making broadcast is listed. Pilots must be listening out on that frequency published for the CFZ, but are able to decide if they want to transmit or not. Good airmanship means a pilot should follow the instructions and broadcast when stated, and especially make calls when they're entering or exiting CFZs, so other pilots are aware of your position and intentions. Common frequency zones are marked on VNCs by lines made up of hollow blue diamonds. It must be noted that it's poor airmanship to start chatting about non-operational items to other aircraft or ground units that you might know personally. Whilst you are talking, all other aircraft will be unable to transmit, and they have to listen to your conversation. Blocking radio waves could result in you being filed on, especially if someone needs to make an important call. There is, surprisingly, a chat frequency listed in the AIPs, 128.95, but remember, anyone listening on that can hear every part of your conversation. Now we can move on to the exam prep part 2 questions. Run through the questions, see how you get on. Do not move on to 3 until you have 100% success rate. Good luck.